everyone, and thank you for joining us in the ROS-Industrial community meeting today. So, in order to double check that you hear me correctly, please send me feedback on the chat window. And I will check with our presenters that we are all okay.
Can you hear us, Mirko? Mirko, can you hear Sweary?
Did he start this?
I think so.
Yeah.
Hey, good evening. Southwest Research Group, can you guys hear us?
German keyboard. Hey, I need to get a keyboard.
Hello there. Can you hear us?
Make the most noise.
Go up to attendees, click on attendees.
You didn't have to keep. And so these have like a rubber diaphragm underneath them. When you press down, it makes contact. Yeah. You can't.
Right click on there. Click on your name.
Like they actually move. They feel better. So like,
click on your
and they
phone.
make it.
Okay, can you hear us now?
Hello everyone, can you hear me right?
We can hear
Can you hear me
Mirko.
correctly?
We can hear you. Can you hear us, Mirko? I can see a little thing on there. Mirko, can you hear us?
Oh, you can hear me.
Okay, there we are. Yep. Okay. So, Southwest can hear me correctly. Aisha as well. Okay, so also Brad. Perfect. Okay, so a couple of minutes more, and then we can get started. So, Paul, you're there?
Yeah, Paul's there.
Okay, so I promoted already Paul to presenter, and he might want to mute himself when he's not talking to me so that we don't hear the background noise of him typing on the keyboard.
Right.
Okay. Super.
So can you,
Yep.
Okay, I'm able to control the slides. Is my slide deck in here?
No, because you can upload one at a time, so it's uploaded, but it's not loaded for show, so to speak. So I think you have to, I have to, pick a different. Actually, you have the change presentation screen. You see that you have just next and previous, or do you also see the?
Next to close. Down. Right there. No, there.
Ah. Okay, there it is. Open, right? Hey, it's working. Okay.
Yeah, like I did the conversion myself to double check that everything was okay, so we should be all set.
Okay, I think you want to take back the presenter?
Okay, so again, so I see the attendees number growing, so let's wait for a few minutes more, also because due to the unfortunate absence of Murilo Martins, we have some more time, which will make taking questions more practical and gives us a bit of leeway. So can you hear me? Okay, so Laszlo?
Hello, do you hear me?
Okay, good.
Great.
Okay, so Laszlo, you're up and running, and Paul as well, just ready. So I already promoted you to presenter. You might want to mute your mic while I am presenting this part. And you know that you are the first schedule. And yes, as I'll go through the schedule right now, you'll see that we'll have a bit more time because Murilo had to bail out due to illness. So yeah, we are a bit less strict.
Okay. Did you receive my presentation an hour before?
Sorry? Yeah, so I uploaded and everything seems to work okay. So
okay, thanks a lot.
Okay, you're welcome. So everybody in attendance, thanks for joining us today. And we can get started. So we are 2 minutes past 6 p.m. Again, thanks to everybody. This is the February 23rd ROS-Industrial community meeting following the last one, which was kindly hosted by Sean Edwards directly from Robo Business in December. This is an online-only event, but we still have a good lineup. So, bit of practical information. So, for contact, so I am the host of this meeting, Mirko Bordignon from Fraunhofer IPA, and I'm also the ROS-Industrial Consortium Europe Program Manager. So if you have general questions or something specific to the European area, please contact me. And then again, for general questions or something specific to your area, which will be the Americas, please contact Paul Vass, which is online as well, and will present later on during the meeting. So, in terms of logistics and very miscellaneous information, so everyone is muted except the presenters, which should actually be also muted right now. And we will take questions via the chat at the end of each talk or mini talk, if you want to call them this way. But then we'll also take the general questions at the end of the meeting. So, and I will to coordinate and moderate those Q&A sessions. The event is currently being recorded and will be posted afterwards for your convenience. Okay, so can some of you double confirm that you are listening, that you are hearing me correctly on the chat? Okay, perfect. Thanks a lot. Now, first of all, we want to thank our ROS-Industrial Consortia members for their continued support, and it's also thanks to their backing that we are able to organize and host these meetings. So thanks again. And in terms of agenda for today, so compared to the agenda which we circulated in the coming days that we were leading up to this event, we had an unfortunate change. Like this morning, I got an email from Dr. Martins from Ocado, which due to an illness occurred during the weekend from which he hasn't yet recovered, had to cancel his participation. However, he will be eager to participate in the future to give us a good overview of how robotics research is currently being done at Ocado, also thanks to ROS-Industrial. So, again, too bad that he couldn't make it today, but that's just delayed. It's not canceled, so we'll hear from him in the future. So after this intro and some short updates that I will now proceed to give you, we'll have Laszlo Nagy from PPMAS, one of our newest ROS-Industrial Consortium Bureau members, which will present his work on the FlexQuery robot interface. Then we'll have Chris Schweizer from Fraunhofer IPA, which will tell us about the Reapp toolchain, which is a ROS-Industrial-based let's say, development environment, tool chain, and in general, development toolkit that is being developed thanks to a grant from the German Ministry of Economics and Energy. Then we'll have Paul Vass update us on the long-term progress of the CAD2 ROS workbench focused technical project. And we'll end with general questions and wrap up. Okay, so in terms of updates, I would say that ROS-Industrial continues to see interest growing along three main directions. And one is what I would call the sentiment of system integrators and of entities close to what I could summarize as application development pain. So they are really people working on the factory floor, seeing what the current needs of industrial robotics and automation is, and finding ROS a suitable tool or convenient means to solve those issues. We have then power users, of which there is quite a history in the two consortia, especially in the North American consortium, where we know that ROS-Industrial has been a convenient means to perform exploratory R&D. And then we have the third line of interest, which is the one from original equipment manufacturers and in general hardware suppliers. I would say that we are going towards the direction of what I would say it's ROS-Industrial officially supported hardware, but more on that in a short one. So as for system integrators, what we're seeing is more involvement from them in the consortia, and we are seeing more application. Sorry, just fix the audio on my computer. Yes, what we're seeing is more application examples. So a very good example of it would be from Laszlo, the first of the mini talks, and then I would say that it really strikes me to see examples of ROS being used in something that wouldn't resemble robotics from typical roboticists like those coming from a service and research robotics background. So I was happy to receive in the last days the first pictures of a leather processing plant, which is now working in a production environment that's being set up by one of our ROS-Industrial Consortium Europe members. And I would say that that's really an example of ROS on the factory floor. Because as you can see, we have a number of machines in a leather processing plant, and the coordination among these machines and the overall control logic is performed with ROS. So its primary use here is as a middleware. I won't go too much into the details. So if you've been at the last ROS-Industrial Consortium Europe annual members meeting, which was held here a month ago, here at the front of our IPA, you already know about it. Now we also have the first media coming out of it. But again, I would say that this is a very good example that ROS is so much more than just the typical examples that we made so far, and it's definitely spreading on a more traditional environment, so to speak. So the second line of development of interest that I told you about was the one of power user, and again, we see continued interest in ROS-based utilities, libraries, development environments. So Dr. Reiser will tell us about the effort towards a comprehensive integrated development environment, and Paul will report on CAD-ROS. And then on a third line of interest, I would say that we are happy to notice that there is a growing number of platforms for which a ROS-Industrial driver of some level of support exists since the project inception back in 2012. However, this also means that it is more and more difficult to provide adequate support for all these platforms. So the next step that we are considering, but I am briefing you on this today, especially to hear feedback, because as you know, the consortium is happy to provide support for the wider community. So your feedback is really important to us. Again, this next step would be to move to a two-tiered support scheme. This to recognize the contribution of our members who kindly support from a financial standpoint development from our IPA, Southwest Research, and our collaborating partners. So a first tier support would be to have a so-called ROS-Industrial officially supported hardware. This is an example of an artwork or a badge that we can have on our pages. This means that the hardware manufacturer for robot, model, make XYZ provides financial and technical support, typically in the context of the two consortia. And consortia managers can then promptly assign engineering resources to handle the support requests. Whereas in case we have no backing from the manufacturer, we can still, and we are happy to provide support in terms of hosting the backend of the driver and coordinate what can unfortunately be a community-based best effort support. This also means, though, that we want to give you means to make the manufacturers aware of the importance of proper ROS-Industrial support as the initiative matures. We think that it's really important to make manufacturers aware of it, so they might not always participate in these meetings, and they might have an outdated view of how the initiative is going. So again, we really want to convey all the needs and the requests from users. So again, that's a tentative plan that we've been considering since the end of last year. I would say after ROS-Con, that we have now been maturing for some time. We discussed it at the ROS-Industrial Consortium Europe meeting. I would like to discuss it with you today, and then to move on to the meeting next week at the southwest of the ROS-Industrial Consortium Americas. So to have it up and running very shortly afterwards. And with that said, without further ado, let's go on to today's talks. And we have Laszlo Nagy from PPMAS talking about FlexGUI. So Laszlo, you're already promoted to presenter. Can you unmute yourself?
I hope so.
Okay, so I hear you correctly. So can anybody else from the audience confirm us that you hear? Okay, good. So I will now mute myself. So the floor is yours, Laszlo. Go ahead.
Hi everyone, I'm Laszlo Nagy from the Norwegian high-tech industrial robot company PPM in Norway, with daughter company in Hungary where I'm working. We are new members to the ROS-Industrial community, and we offer the new graphical user interface FlexGUI as a free-to-use software for you. PPM is development partner to the Japanese robot manufacturer Nachi, which is currently using the previous version of FlexGUI as a standard part of their controller. It's based on our new FlexGUI is based on ROS, as you're going to see in the following minutes. The basic idea of FlexGUI is to make the UI so intuitive that someone without any previous training or scientific background can use the software with confidence. This will help to break down the barrier to operate robots. On the left side of the screen, you can see the screens that contain task-specific setups you can switch between any time. All FlexGUI widgets, we can call these widgets, are visible on the list on the right side of the screen in edit mode. You will see on the demo. You can simply drag and drop them on the screen without a single line of code or reading manuals. This can be done on the target device as well, so no need for any compilation at any time. And what's also a great thing in this, that this can be done also by the designer. So you as integrator don't need to mess with PDFs or images, and he doesn't need to code. If you want to go deeper, you can. FlexGUI is written entirely in JavaScript. It's running in a browser, actually. This means it will run on all devices where you can open a web page. PC, phone, tablet, all compatible. There are properties for all widgets you can change. All widgets can react to clicks, where you can call ROS functions or JavaScript functions. You can also download other JavaScript libraries from the internet and install them as you like. Properties are not just simply numbers or text, but expressions. You can set the width or value based on values from ROS or other JavaScript components. To subscribe for a ROS topic, you only need to check a checkbox. Again, no coding. This makes FlexGUI a great tool for teaching ROS, lowering the knowledge required to start using it. Let's make my first demo. It will be a bit laggy because of the lack of video playing. So on the left side, you see the screens. I'm going to click on the Add Screen icon on the left. This way I make a new screen. We have factory screens you're going to see later, and normal screens. I make a normal screen now. And then from the right column, I just pick a progress bar and place it on the screen. It can be done, I emphasize again on the tablet, so you will see it on the final resolution and the final device. And then you can edit the properties of these widgets you place down. And as you see, the value is not simply a variable, but it's an expression. So you don't need additional code to set the values of items. You can set it in place. Then I assemble this screen in like 2 or 3 minutes. And as I press the next button, it increases the value of a variable. It blinks the lamps. It shows the progress bar moving. It's a very simple example. And all this project is saved on the ROS itself. So if I open another device, other browser, on the right you see a Firefox, the left is a Chrome, then it's real-time updated, so you can use your PC or your remote PC to modify projects, and it will be modified on the target device or on another country, actually. Now back to the slides. FlexGUI is a UI tool. You should not make complex logic in it that requires lead-time operation. But you have the tools to connect to a robot. This runs its program at an industry standard safe environment and communicates with FlexGUI just about parameters going in and out. To assemble test benches in FlexGUI is the perfect tool. No key codes, no batch files. You click a button and see the values on the screen. You don't need to throw this away when moving from the test phase to the production phase. If you are planning to use more complicated ROS logic, you will still need a UI to interact with the user. FlexGUI can communicate with all ROS components because of the flexible communication layer, so no extra coding is required, even if you upgrade your existing software. The ROS connection works very smoothly. When you open FlexGUI, it queries all components from the ROS core, then keeps this list updated. If a new node is connected, you will see it right away. You can check what topics you want to access, even give them simpler names to keep your JavaScript code easy to manage. If there is a change of a topic, you can also run scripts, like showing message or a specific screen. And now it's time for demo 2. So here you see all the nodes in my ROS. It's running on a Raspberry Pi now. And when I select my node, it's our own development, an interface for Nachi robots. Then you see all the services and topics it offers. And what's really important to see is the count and the enabled friendly names. We will use that later. And I also have to check the subscribe checkboxes to receive all the latest data. Then I place down the progress bar, and in the red circle you see I use this value count that's coming from a topic. It's updated real time as the robot changes it. Then you see progress bar already working. Then let's put down another control where we can control what's going on the robot. As you see, I'm showing the value enabled, and on the on-click script, I'm using standard ROS bridge calls, so no new protocol you need to learn. And with this, I will change the value on the real robot. And it's already finished, and when I'm clicking that boolean, it will switch between true and false. And here you see the robot program that's running. So it's simply going through the variable 1 that we renamed to progress, and variable 2 is switching between 0 and 1 that we renamed to enabled. So this is how simple it is to add the UI to your existing project. FlexGUI 4 is quite focused on Industry 4.0. We believe that ROS is a great middleware to work with. So you can wire your whole production system using ROS, then make the specific screens for specific components, and one or more overview screens like this. You can click on the lamps if one of them reports an error, so gets red, and see the details. You can also show it on a big screen to monitor the system's or the shift's performance. You don't need to be a Photoshop expert to assemble your current overview, because FlexGUI has a built-in support for that. In the factory designer, you can place fences, roads, devices as widgets, then customize them and build your own layout. After the layout is done, you can set up links to screens. So when you click on a specific item, you are navigated to the screen describing it, and no need to remember which screen is which. This comes very handy, for example, if you have more cameras, because then based on the layout, it's clear which one you want to open. And here is the third demo, my last one, the factory designer in working. Now you see it doesn't fit in the screen. So what I can do is zoom out. Because it's a website, it's extremely flexible. So even if you change to a totally different size of screen, it's just Control plus and minus, and it's done. You don't need to redesign anything. And how you set up these links to other screens is just a drop-down list. So again, I don't think you even need to read the user manual, but I suggest you. And the project you have in FlexGUI is available offline as well. You can download it, upload it to other devices, save it for later, or store in your version control system. This way, you don't need to be in the factory to set up everything. It's very simple to do remotely. About remote control. Most of our customers are struggling with the big distances they need to travel to support their clients. We made FlexGUI expert site for this purpose. You can see all your factories at one place, get reports, alarms, and react to them using remote view. There's a two-way video, voice, and text chat also to have an integrated solution. The client can call in using one single button, and the expert can use the built-in knowledge base to find the answer fast and efficiently. We also have solutions for data collection and analysis, so you can handle big amounts of production data efficiently and make charts, studies automatically. You can also set up alarms that trigger sending of email, SMSs, so you have minimal downtime and costs. As a new member of the ROS community, we offer the packages you see with a check mark as open source, so you can further customize yourself or contact us to help with your needs. Other features will be available in separate packages. We also have a long history with R&D projects and partners, so for universities or research institutes, we usually hand out gratis licenses. All you need to do is send us a mail describing your needs. And thanks a lot for your attention. Sorry for being so hasty. I hope I managed to get you interested. We are happy to answer all your questions through email or phone, or if you prefer personal as well. We are going to present next week also, or be present in the ROS meeting at San Antonio. So I hope we can meet. Thanks a lot.
So thank you, Laszlo, for the presentation. I think also on behalf of our attendees. So you took the time to come here at the meeting in January to come to present at the community meeting, and you will actually come to San Antonio next week. So, great service to the community of making them aware of this new package, which actually we are working on the specifics. So it's about to be contributed to the ROS-Industrial organization on GitHub. And we will keep you posted on the details as soon as this happens, but expect it very soon. So, if there is any specific question that you would like to be answered right now, so you have Laszlo's email contact, but otherwise we have some time for a few questions maybe. I see that the chat is pretty silent. So, if there are no specific questions, we might want to move on to the next presenter. Okay, so change the presentation, and we now have Ulrich Reiser from Fraunhofer IPA, which is actually sitting next to me. So happy to pass him the mic, and he will tell us about the effort which is ongoing here and at some partner sites about reusable applications for flexible robot-based automation systems. Ulrich, the floor is yours.
Yeah, thank you very much for handing over. Hello, everybody. I hope you can hear me. So I have the pleasure to present Reapp. Some of you might have heard of the project before because it was presented at the ROS-Industrial Consortium Europe meeting in January. For the others, I will just quickly tell you what kind of project it is. So it's a research project funded by the German Ministry of Economy and Energy. It's a 3 years project, and the goal, as the title says, is to enable reusable applications on the basis of ROS-Industrial. So you see the partner list. It's 12 partners, German partners, consisting of 3 research institutes, so FZI, KITS, and Fraunhofer IPA, who are providing the basis, but then we have also technology partners like SICK providing their input, and we have also end users, so BMW, Fisher, and Dresden Electronics, who bring their use case to evaluate the tools, and we're developing in the project. And we have also 2 system integrators in the project, so we have the whole chain of involved parties in the project to be able to evaluate what we're doing. Let me motivate again what we're doing in Reapp. So if we have seen this analogy of androids and robotics several times, I think. So there's the commonality is certainly the heterogeneous hardware. We have also sensors, HMIs, computation, and so on. And we have this reusable software in form of apps. So that's certainly the same we want to achieve in robotics. But in robotics, we see some differences. So we have not only heterogeneous hardware, we have a structural variety of automation systems. So not only robotics, there's periphery, there's PLCs and so on. So we have a larger possible structure of hardware involved. And then even if you have the same hardware components, the same parts, and your geometry is different, then you will not be able to reuse your application. So as a difference to the smartphone world, we're convinced that monolithic apps will not be reusable to a large extent. So you need to think of connectable, configurable software building blocks that can be reused, and we will also think we need a part, so the integration, we call it integration platform between the hardware and the repository because of this structural variety. So let me look with you to this ecosystem of Android. So we have said before the App Store, then the App Store, and we have the hardware environment, but we have several other layers in between. So first of all, the runtime environment, Linux, and hardware abstraction layer. And then we have the runtime, and we have also SDK tools which provide the basis of generating this mass of apps, making the hardware platform interesting. So in Reapp, we see the following analogy. So we have, on the one hand, also these heterogeneous and robotics and automation components. And on the top, we have similar to an app store, the so-called Reapp store, where we provide, so it's a repository. We want to provide these reusable building blocks. So it could be also similar to Ubuntu Snappy core. And in between, we have layers. We see layers that are also required to make this reusability functional, working. So we have also the Linux kernel. We see ROS-Industrial as the hardware abstraction layer. And on top, we have a deployment environment which allows easy deployment of these apps located in the store. And which I think is almost the most important part, we develop an SDK which makes sure that apps that are developed based on ROS-Industrial are compatible and can be configured and combined easily. So let me go a little bit into detail. So if you see again these 3 layers, so the cloud layer where we have the repository, We have the hardware layer where we have the pilot demonstrators. So in Reapp with 3 pilot demonstrators who want to show and evaluate the concept. We have the integration platform, which is connected to the hardware and is connected to the repository physically. So which is this, which really connects or where we can deploy our components. And in between, we have this Reapp engineering workbench, which we see as a tool chain from the modeling of components until the deployment environment. So we look at the whole development process in different roles. So first of all, we'll take the hardware component developer. So he might not be take a sensor developer. He might not be knowledgeable of ROS. But we want to support this role in writing an app or a driver component for the ROS community. So this is possible by the component modeling tool, which is a graphical user interface that allows the component developer to define the interfaces of his component on a model layer, develop his component, and at the end of the day, when it's finished, put it into the cloud layer in a build farm, a test framework where we have maybe the label ROS-Industrial approved, and we can make it available in the store. The same holds for software component developers, which create software components that are hardware independent. And then we go to the next tool, which is called Skill and Solution Modeling tool, which allows to compose these basic driver and basic components, software components, to complex skills. So we would here have maybe a driver for a SIG laser scanner and maybe a localization component, and we could build a navigation skill from these, for example. So this would be the part of the system integrator, which could also provide these skills already in the store, or create a solution. So the solution is specific, a skill configured specifically for a certain hardware. So it would be a navigation on Neobotics or whatever mobile platform, for example. So you keep in mind that this is also only on model level, and so if you want to make or install these apps and these skills on your hardware, you have the deployment environment, which provides the possibility to install, to deploy the apps on the integration platform, and it's also possible to use simulation in a virtual deployment environment, or even deploy some parts of the solution on the cloud. And so the frame, which I think is one of the most important things we do at Reapp, is creating semantic structure for these models. So all the interfaces, all the types are specified or classified. So you can see it on the next slide. So we create the so-called Reapp ontology, where we classify different hardware types, we classify different software types, and we classify capabilities that are associated to software and hardware types, and provide also the different dependencies. We can provide attributes. We can provide ROS interfaces, and by these classification, we give, for example, a system integrator the possibility to easily search for existing components on the store, which are suitable for the task he tries to solve. And Also important is that you might have, if you only look at syntax or interfaces described by ROS topics or ROS types, for example, you might sometimes it's ambiguous. So you might have an image data type as an interface, but you don't know if it's a 3D image or 2D image. And so this ontology or the semantic frame provides a clear and unambiguous classification of all the types. So then if you create a new component, you have also to classify these components with respect to these to the ontology, and then you have this support of the component modeling tool, which I will show in a second in a video. First, I want to show you how the existing apps are then composed. So it's this, you can see here the skill editor. Either you load it from the App Store, which is external possibly, or you have a local explorer of your local apps. You can connect them, combine them, and so the skill editor checks if your links are done correctly, or not only the syntax but also the semantics of the interfaces are checked. So you can build, so to say, your software architecture you need for a specific skill or solution. And then, of course, you need a sequencer for your application. This is done in the so-called coordinator, which is, there's a small sub-tool providing an easy way to create your state machine. Yes, then I now want to show you the component modeling tool. So we have to switch to a YouTube video.
Yes, Paul, I see while we are loading the video, I see that you're asking whether this is built on Bride. And yes, so Bride is the backend that takes the model and then generates ROS code. Ulrich, please, if you need to comment the video.
Exactly. A good question. So, of course, the models need to go to the implementation. This is done by the code generation tool based on Bride's templates. So you see here the wizard. You can so assume you're a hardware supplier and you want to create a driver for a universal.
So there's a voiceover.
Okay, good to know.
There is some.
Okay, so read it.
Yeah, so you're after the video, you're almost done.
Yes. Show the video in the
no, actually there I did a shorter presentation, both because it was not as comfy on the material and also because something else went a bit long, so I used components. No.
So, when should I announce the release of this?
Ask somebody else.
I know you're not the release. You're the one who's
the internal release.
Yeah.
So maybe the mic is not on. So I'm not committing for April, so you're cool. I cannot physically do it. I mean, I'll have it travels internally, so.
It's planned. So
but if you already know that the plan is not coming together, nobody was asking for like do it now. Like you don't have obligations towards them. Okay, so somebody will do that. Okay.
Okay, so I have to switch me back.
Yeah, well, I guess you do that automatically. Okay. So there we are. Sorry for not realizing that let's open the slides again. That the audio was cut while the video was playing. Okay, but there we are again. So Ulrich had a commentary on top of it, which you probably lost, and then we realized that yes, the audio was cut. Your call, Ulrich, on whether you want to summarize this, but
yeah, exactly. So maybe just one sentence too. I hope you could see what happened there. So it showed a wizard how to create a new component for let's put it the Reapp ecosystem. Creating a model based on the classifications, until the code generation was not shown yet. So there were questions on when this is planned to be released. So maybe I will just go one slide ahead. So the frame of the Reapp project is that we have now the final project year. So we have to create all the results this year, and we have a first presentation on the Hanover Fair, which is end of April, and we plan to have a first release, maybe not of the full functionality, but a first release that can be checked out by project external people and around this date. Then we also have open innovation camp planned, where we combine the presentation of results from Reapp and SME robotics, which will be slightly after Hanover Fair, and we also plan to involve other small and medium companies, especially system integrators, to evaluate or for a hands-on workshop later in the year to evaluate the tool chain and give feedback and to see for us what is good and what is maybe still missing. So we now plan also to further dissemination, possibly at ROS-Con, maybe also EclipseCon because it's as a Eclipse plugin. And further conferences which are planned in the frame of this year. Are there any other questions? I'm not sure if I say we have time for it. Otherwise, you're invited to contact me or just ask Mirko, and he will certainly,
Yes, again, forward all specific questions to Ulrich. And okay, so if you don't have further specific questions, then we have Paul Vass for the next presentation. And Paul, you're unmuted, are you?
I am now.
Okay, so I can hear you well. So I'll mute myself.
Okay.
And the floor is yours. Go ahead, Paul.
Good deal. So yeah, thank you all. Very interesting presentation so far. I'm inspired. I'm glad to see all the extra work on kind of front end tools for ROS. I think we're seeing a theme there, and to kind of follow on that theme, we have a third one for you. So certainly within the ROS-Industrial Consortium Americas, we've heard a call for maybe some ease of use front-end tools for work cell setup, and this has more to do maybe as juxtaposed with an IDE, this has more to do with the configuration of the physical components, sensors, and such for a work cell. So on this first slide, you see all the different files that a knowledgeable ROS user will interact with to set up a work cell. So things like, for interacting with RViz or TF, or for inverse kinematics, you're going to need to manipulate text files for a URDF, a Zacro, and macro Zacros. And that's kind of a skill that has to be learned currently, but it seems like maybe a GUI front end for that would assist people in kind of making manipulation of those files much easier. Similarly, in industrial robotics, you see Cartesian paths are necessary to define oftentimes, and those are maybe just comma delimited or APT or STEP and C files. It'd be nice, again, if those were easier to kind of automatically pull into ROS. And you see some of these others are kind of on the roadmap. So we envision kind of a 3D front end for all of ROS-Industrial. We're just calling it our 3D workbench, really. And that vision will be accomplished in 5 milestones that you can see here, and we're on the first milestone. As you'll learn a little later, the first milestone is funded by Boeing, so we're very, happy for their support. So that first milestone is a URDF editor, and there's kind of a very simple tool that we're looking forward to here that really enables a non-expert user to manipulate the values and tags in a URDF through a GUI interface, so they don't have to be knowledgeable about the standard or the proper tags for different objects, and also import geometry to associate with various links. So you can see kind of our status. We've presented this tool before at our ROS-Industrial community meeting, but at that point it was just kind of conceptual and it hadn't started. So now we're actually underway. We're funded as of the end of December, and we have 4 months to complete the project. I'll talk a little bit more later about kind of the programmatics behind it, but it is kind of a community-driven activity where we're helping to administrate it, but most of the work is getting done on kind of a volunteer basis. So here you can see kind of the high-level functionality of the URDF editor and which things are done and which things remain to be done. So basically the items that you see in brackets that have a little done next to them are completed, and if you're part of the project, you're able to access that and use it with that amount of functionality. So it's kind of a good encouragement to get involved. It's usable to a degree, even as it's work in progress. So this is just kind of an example of what can be done so far. You start with kind of a blank slate, open a URDF file or create a new one, and what happens, say in the instance that we open an existing URDF, you can see all the different properties related to a given link or a given joint, and then you're able to go and manipulate the value of those properties, and you immediately see them change kind of on the screen in RViz. So one might argue that, well, you could just manipulate a URDF in a text file and then go and see it change in RViz. But even doing that takes quite a bit of back and forth by the time you save it in the text file and then kind of relaunch RViz. So this kind of automatically updates RViz on the fly, so you get kind of a nice fast feedback loop so that you can just manipulate values and immediately see the change in your results on the GUI screen. So for some programmatics here, we are running out of private GitHub repo, and you're going to say, well, why are we talking about an open source project that's in a private repo? And the answer is that it is open to the ROS-Industrial Consortium, and it will become fully open in no less than 2 years, and possibly earlier. Talk a little more about that. So yeah, it's kind of a good reason to be part of the ROS-Industrial Consortium. It's a privilege for members that they're able to work on it. So work on it and access it before that 2-year time frame is up. terms of our contributors, it is a bit of a novel project. In normal terms for the consortium, we run these focused technical projects, and those are generally sponsored by a group of companies, and then the work is performed by a combination of performers that are often including SWIRI or Fraunhofer and such. In this case, we actually have the technical overseer is TU Delft, and the folks kind of doing the work, the developers, are again working on a volunteer basis, and the benefits of doing so is that they have access to the project, and they also have kind of that control to add features that they care about. At this point, we're basically creating issues on the GitHub repo and then assigning those issues to folks who've volunteered their time. As far as the administrators go, Mirko and myself are recruiting folks from our consortia, from the companies who are part of the consortia to help as they express interest. And yeah, our schedule will have an alpha release in May, and we're planning to generate kind of the ongoing maintenance support for the project through a beta download, if you will. And so we'll basically make a beta available to download, and we'll gather some funds through the release or through purchase of the beta. That beta will be a binary, and it'll be something that you download, I guess, as a Debian. Once we accrue enough to maintain it, then we'll basically release the whole thing open source. So that's how things could move along more quickly than the 2-year time horizon that I mentioned. I'll note that there are also kind of government funding sources that may come into play that would accelerate this as well. So if one of those other funding sources kicks in, then everything will just go open immediately. So I think, here we go. We are featuring Gijs van der Hoorn a little bit. Just to give you a little background on him, since he's the tech lead for the project. So he is with TU Delft, and he's been a great help to, let's see here. It looks like he might be commenting, but anyway, he's been a great help for ROS-Industrial throughout the past 4 years of our existence, and we'd love to continue to engage Gijs in these ways through project administration, and in this case, he's reviewing pull requests and setting direction for the project. So really glad to have him doing that. Okay, and there's my contact information. That's kind of a wrap. I don't know, Mirko, if we have any other. Sure, looks like we're going to try and make Gijs a presenter for a second here. Oh. I think he'll have to unmute himself. Oops. I guess he's busy. So yeah, I guess that summarizes the milestone 1 progress at URDF editor for the CAD to ROS workbench. Thank you all for your time, and of course for your support in the ROS-Industrial community.
Thank you, Paul, for giving us an update on the project. And yes, as Paul said, we are actively recruiting developers from the 2 consortia, so feel free to contact us. And again, this is an effort which follows, I would say, a bit of an unusual format for what concerns FTPs, but we also look forward to this new model. So stay tuned in the next months, especially this beta release, which could unlock the source before 2 years. Okay, so now it's time for final questions and wrap up. So let me just change presentation. So, well, first, if there is any general question, some specific question for Paul. If not, some general question concerning the issues and the topics that we discussed during this meeting. Again, I would really like to hear your feedback on the move towards a two-tier support for hardware. So we were really happy to see hardware manufacturers joining the consortium. Actually, the two consortia. As you know, Yaskawa Motoman was one of the very early backers. Then let's say that we had a few more. Then things were a bit timid, so to speak. But we had new hardware manufacturers joining lately, like Rethink Robotics, Blue Workforce. Very happy to have those innovative robot manufacturers on board. And again, it's both to give justice to our supporting members and also to prioritize technical development. Now we have many drivers, and I know that for some of them there is a lot of support requests. So hopefully this model will convince other manufacturers to jump on board and provide resources to do a better job. Okay, so feel free to send the feedback to me by email. Now, wrapping up, I would like to advertise a few of the upcoming events. So next week, we have the ROS-Industrial Consortium Americas annual meeting, hosted by Southwest Research in San Antonio. A number of us from the ROS-Industrial Consortium Europe will be present as well, like myself, PPM AS, and also actually the CNR-ITIA, so the Industrial Technologies and Automation branch of the National Research Council of Italy. So there will be a good representative from Europe as well. So if you're there, it's a good chance to catch a number of us from the worldwide community. Then we have developers training, again at Southwest in early April. And then we had the chance to organize. It's sort of a last minute thing, but since there was a chance to do that, we jumped on it, and you will hear more details shortly. We're finalizing the program, but there is an event which is co-sponsored by the ROS-Industrial Consortium Europe that will deal with legal and economics aspects of open source software in industrial robotics and automation. So, as I like to say, since technically the project is advancing at a very good pace, and technical staff and companies is buying our value proposition more easily than in the past, the next obstacle is to convince that the proposition is sound from a legal point of view, like licensing, liabilities, these kind of issues, and also that it provide a way to have things being viable economically. I personally believe that Linux and other projects showed us that this is the case. They did it 10 years ago in IT and other businesses, but there might be some nuances and peculiarities of our domain that needs to be addressed. So save the date, April 19th and 20th, and through our conventional channels, you will be updated on the program. Again, here's our contact information, but if you go to rosindustrial.org, it's pretty easy to get hold of us. And again, thanks to our sponsors, to our members for sponsoring this event, and for providing, again, financial support so they can manage the initiative. So I think the meeting is officially over. However, I will stick around for some more time. So in case you have questions, feel free to use the chat. And again, thanks everybody for your attendance, and to our presenters for their kind talks. Thank you.
Hey, Mirko.
Yes.
Hey, is Ulrich still there?
So he's not in the room, but I can get hold of him.
I was just interested to see a little bit more about the IDE that you're working on.
Okay, let me go and get hold of him. I'll be back in a sec.
Okay.
Okay, so I'm here with Ulrich. So Paul, you're still online?
Yeah, we're still here. So
There we go.
Ulrich, it's fascinating to see what you're doing with Reapp, and was just eager to hear a little bit more about maybe some of the narration that we might have missed during the video. If you had a little more time, could you dive into the part where you're kind of building the application out of components?
Yeah. So,
you want me to load the slide?
Yeah, maybe.
Okay, so we'll go back to the presentation. Okay.
Okay, so that was okay. So assume that you have created these components with the component modeling tools, which has certain interfaces and is classified regarding to the ontology. So you have found it on the App Store maybe because you looked for a later and you found this component. Then you just open this tool editor and you compose these different components to a new skill, a pick and play skill. For example, you might need then a perception capability, and you can just look in the App Store for perception capabilities. You get maybe a software component which is dependent on a certain camera, so you can draw all these models into your skill editors. And your skill editor can connect input and output or the interfaces of your apps, and then you have to create this coordinator, which is doing the sequencing. So you might have a certain.
So you have quickly. Is it signal flow on the left and state flow on the right?
Right, exactly. Yeah. That's
Beautiful. Yeah, we've wanted that for quite some time, and I'm really excited that you've already done it. Essentially.
So I mean, it's not a product yet, right? So we as I told you before, we aim at April for a first release. So the goal would be really to have a tool chain based on Eclipse, and maybe also find a partner from industry who is taking this tool chain. So like ITMIS, for example, we're doing Eclipse plugins professionally. I think that would be really great to have a professionally supported tool chain, maybe in the time frame of 1 year or 2 years. Because I think what's really would be helpful is to get this standardization of semantics of life cycles, and so you can do a lot of things in your component model, which standardizes the way ROS components are written. And I think that would be a very important step also for quality assurance.
Got it. Okay, yeah, thanks for taking time to clarify that. I love it. So we'll be excited to play with it when it's released.
Okay. Yeah. So actually, I think we have already done one eager external user that could serve as a tester. Yeah, as a tester. So okay, good that we have some pressure to make it usable to people who are not deep into the project. So thanks for offering them to serve as such. Okay. So again, to everybody, if you have any more questions, otherwise I think that at this point I can end the meeting. The recording again will be posted on the ROS-Industrial website this week. Actually, could be already tomorrow. We'll just write a blog post about it. Anything else from your side, Paul?
We're good. Thank you so much.
Okay. Thanks, everybody. Bye.